A student measures time t for one complete oscillation of a pendulum of length L. Her results are shown on the table. She uses the formula t equals 2 pi under root L upon g. This is an equation to calculate the time period of a simple pendulum that maybe you study at higher level. To calculate the expression of free fall g, what is the best estimate of percentage uncertainty in the value of g? Okay, since we are supposed to calculate the percentage uncertainty in the value of g, you have to make g your subject. Okay, so in order to make g your subject, you have to make square on both sides. Because g is under square root sign, we have to get rid of square root sign. So it would become t square is equal to 4 pi square upon g. Square will be there in all the numbers. It will be there on 2, it will be there on pi, it will be there on these two as well, but these two are already under square root sign. Square root will be cancelled out. Anyways, g will be shifted there and t square will be shifted on the other side. G is equal to 4 pi square L upon t square. This is my main equation that can be used to calculate the percentage uncertainty in the value of g. Okay. Anyways, so we have two constants that does not have any uncertainty. I forget it. Okay. Yes, L and t square. So for L, I'm taking the percentage of L 0.001 upon 0.42 multiplied by 100. This is the percentage of L. Plus, since t has a square and this exponent is always multiplied, okay, 2 multiplied by 0.1 upon 1.3, okay, multiplied by 100, right? I expect you to do the calculation quickly. 15.6%, that is to two significant figures, 16%, and D is our correct answer. I hope you get it right. So remember one thing, whenever we have to calculate the percentage uncertainty in some variable, this variable should be the subject in the equation. Once you make the subject in the equation, then you solve it in this way and you will be getting the answer. Okay. Strain energy W of a spring is determined from its spring constant K and extension X. The spring obeys Hooke's law and the value W is calculated using the equation W equals half kx square. This equation we'll be studying in the coming chapter, deformation of solids. The spring constant is 100 plus minus 2 Newton per meter and the extension is 0.050 plus minus 0.002 meter. What is the percentage uncertainty in the calculated value of W? Okay, let's calculate. See, W is already the subject. We don't need to rearrange the equation this time. Okay, and you know, half is a constant. I don't need to worry about it. Okay, but I need to work on K and X square. So K does not have any exponent. It means it has an exponent of 1. So what we need to do, we simply calculate the percentage of K, that is 2 upon 100 multiplied by 100. This is the percentage of K. This is K. And then we are supposed to work on extension. This is extension. Remember, extension has a square in the formula. So we need to multiply this by 2. 2 multiplied by 0.002 upon 0.05, right? So multiply by 100. I want you to calculate it, please, quickly. So you get 10% is your answer. The answer is B. Okay, so this is also sort of the same type that we did before. In a simple electrical circuit, the current in a resistor is measured this. The resistor is marked as having value of this much. If these values were used to calculate the power dissipated in the resistor, okay, what would be the percentage uncertainty in the value that is obtained? Okay, so we need to calculate power. We have current and we have resistance. Once we study the chapter current electricity, we will get to know that there is an equation of power in terms of current and resistance. P equals I square R. Okay, so we need to calculate the percentage uncertainty in the value of power. I has a square, R does not have a square. So it means we need to work on the percentage uncertainty of I. I is 2 times. See, this is actual uncertainty. So 0.05 upon 2.5. Remember, although the unit is not a standard, but for percentage uncertainties, we don't need to convert the unit because the factor comes above and below will be cancelled out. Okay. So 2 times out 0.05 upon 2.5 multiplied by 100. This is the percentage of current only plus the percentage of resistance. The percentage of resistance is also already given. We don't need to convert it into percent. Okay. So we simply need to write 2 here. I hope we get it right.
Yeah.
So it's going to be 40. Yes, please calculate it, please.
I'm getting 6.
6%. Okay. It means C is the right answer. So remember one thing, we have to be careful. We have to see what type of uncertainty is given to us. If it is percentage uncertainty given, so we need to take it directly. And if it is actual uncertainty, just like current here, so we need to calculate the percentage. Okay, so hope you understand it. Value of k is to be calculated, right? So k is again in under square root, so we have to get rid of square root, right? And for that you have to make square on both sides. Okay, so once you make square on both sides, it will become v square is equal to k p upon rho. Make a big difference between p and rho, otherwise you will be confused. Now let's make k our subject. K is equal to v square times of rho upon p. Let's substitute. Substitution gets us v square. Check the value. Value is given in standard units. So 3.3 10 exponent 2 square, okay, into rho. Rho is also given in standard unit 1.29, no exponent, okay, upon, okay, upon p. P is given to us as 9.9 10 exponent 4. Okay, please use calculator and calculate it in one go.
1.4 is 1.
1.42. No 10 exponent, right?
Yeah.
1.42. We can give the answer to 2 or 3 significant figures here. No worries. Yes, here we have to be careful about the significant figures. Use your answer and data, determine the value of k with its absolute uncertainty to an appropriate number of significant figures. So see, absolute uncertainty, we need to work on absolute uncertainty again, carrying forward the same equation. K is equal to V square rho upon P. V square, so since there is a square, so I have to multiply 2 by the percentage of V. The percentage of V is already given to us, 3, okay, plus rho. Rho has a percentage of 4 and rho does not have a square, neither any other exponent, so I'm just taking it directly 4%, plus P has a percentage of 2, okay, so 6 twos are 12, 12 plus, sorry, 2 threes are 6, 6 plus 6, 12, 12% is the answer. Yes, now we need to work on the actual uncertainty. 12% means 12% of my answer is the uncertainty. Okay, so 12% of my answer is uncertainty. Please calculate it. What is the answer? 12 upon 100 multiplied by 1.42.
0.17.
0.17. To appropriate number of significant figures, if you remember, our absolute uncertainty, final absolute uncertainty should be written to one significant figure only, must be equal to 0.2. Okay, so 0.2 only. I rounded it, right? Since it has one decimal place, so my answer should also have one decimal place, 1.4. Okay, so this is going to be the final answer. Let's check the final answer. Okay, in the mark scheme, give me just a minute. Okay, there you go. Yes, the value of k comes 1.4 or 1.42. You can write it to three significant figures as well, doesn't matter. And percentage comes 12, and the answer comes 0.17. You rounded it to 0.2. Okay, good, fine. Firstly, here we substituted the values 25, okay, on pi. D squared, D is given in millimeters. Okay, and your answer is 1.99 10 exponent 8. This is pretty simple. Now, percentage uncertainty. Again, we need to work on the formula. Okay, formula is here. 4 is just a number. You don't need to work on uncertainty of 4. Pi is just a number. No need to work on its uncertainty. Only f and d square are the two variables here whose uncertainty to be worked on, f and d square. F does not have any exponent, so it means it has an exponent of 1. No need to multiply any number. So for the percentage of f, 0.5 upon 25 multiplied by 100. This is the percentage of f plus 2 times of, because d has a square, 2 times of 0.02 upon 0.4 multiplied by 100. This will get us the percentage uncertainty in the value of sigma. Okay, so what is the answer?
Um, 12.
12%. 12% is the answer. Okay, now we need to calculate the actual uncertainty. Okay, with the answer and appropriate number of significant figures. We know the number is 1.99 10 exponent 8. So 12% of 1.99 10 exponent 8 is to be calculated 12 upon 100 multiplied by 1.99 10 exponent 8. Okay, so tell me what is the answer?
Should I tell you in standard form?
No, you tell me simply the answer.
I think it's better if I say it in standard.
Okay, good, tell me.
2.4 into 10 exponent 7.
10 exponent 7. Okay, this is the uncertainty. Now see the answer and the uncertainty. First of all, they are indifferent and exponent. And one thing is we need to round it. 2 into 10 exponent 7. We rounded it to 1 as a only. Okay, now see 1.99 10 exponent 8 and 2 into 10 exponent 7 are such numbers, that have different 10 exponent. So I have to get the 10 exponent same. Okay, 10 exponent for this one is 7. I have to make it 8, and we can make it 8 by taking decimal backwards. Okay, 0.2 10 exponent 8. 2 into 10 exponent 7 is equal to 0.2 10 exponent 8. Now I can write the answer 0.2 10 exponent 8. Since it has one decimal place after rounding it to 1 SF, so it should also have one decimal place. 1.99 should be rounded to 2.0. Okay, 10 exponent 8. This is going to be my final answer. Okay, I repeat, since my uncertainty comes 0. Since my uncertainty comes 2.4 10 exponent 7, I have to round it to 1 SF only. This is 2 into 10 exponent 7, and I have to get its 10 exponent same as the other one. So once I make it same, like I convert 7 into 8, I have to bring the decimal backwards. It's going to be 0.2 10 exponent 8. Okay, so I wrote this answer. I found in my uncertainty there is one decimal place. I rounded 1.99 as 2.0. Okay, and write the final answer. I hope you understand it, right?
Yeah.
Okay, now I'm going to show you the answers. The answers are here on the screen. Yes, the answers are correct. 2.4 10 exponent 7, and final answer to be written either in this form or in this form. Okay, yes, correct answer. Okay,
Yeah.
fine. Okay, first definition is pretty easy. Mass per unit volume. It's called density, right? And then you calculated the diameter, right? So d cube, making the subject 6m upon 5 times of rho. And since it has d cube, and we need to calculate d only, we have to take cubic root on both sides, right? So
Yeah.
cubic root on both sides will be taken. Yields per. This will be cancelled out. Eventually, d is equal to cubic root means the exponent is 1 upon 3. 6 times of mass is given in standard form, 7.5 upon 5 times of rho. Rho is 8100, and cubic root again, exponent 1 upon 3. Or you can take cubic root in your calculator directly. Okay, so you calculated it and your answer comes 0.12.
1, 2.
What number comes after 2?
1.
121. Okay, fine. You can take it 0.12. Now the next is use your answer in modern data to determine the value of d with its absolute uncertainty. Okay, so absolute uncertainty will be calculated, but this time needs to be very careful. This 1 upon 3 is the exponent. This should be multiplied by all the percentages. We don't need to work on the uncertainty of pi and 6. Only, sorry, not here. Pi and 6. Only mass and density uncertainties would be taken. Okay, and along with 1 upon 3. Since 1 upon 3 is the exponent. Okay, 1 upon 3 multiply by percentage of mass, that is 4. Already percentage given, no need to work on it. Plus 1 upon 3, the percentage of density, 5. Okay, so I think it comes 9 upon 3 if I'm not wrong. So percentage comes 3%. Okay, could you please check it?
Yeah.
And your percentage was coming 9%, if I'm not wrong, since you have not considered 1 upon 3, right? Okay, so 3% of my answer is going to be the actual uncertainty. 3% of my answer. Will you please calculate it? What is the answer?
Um, 3.6 into 10 raised to minus 3.
3.6 10 exponent minus 3. Okay, if I completely finish its 10 exponent, so it would be 1, 2, 3, 0.0036. Okay, 0.0036. I should round it to 0.004 only. This is my answer, 0.004. And my answer comes to 3 decimal places. So you have to go to your previous answer. 0.12, was that 121?
Yeah.
And what number comes after that one? If you round it, will you please calculate it again and tell me the
It was just that much.
0.121 only. That's it.
Yeah.
Okay. So your answer should be 0.121. This should be your final answer. Okay. I hope you get it.
Yeah.
Again, there was a problem in only taking exponent as multiple. Okay. Now I'm going to show you the answers. Okay, the answer is okay, what was the question? Yeah, this one. 0.121, 0.004. Okay, is the correct answer. So need to be careful about these multiples, okay?